Hi there everyone. In this little lesson we are going to be looking at natural logarithms. So logarithms here to a base not of 10 but a base of e, Euler's number. So they're called natural logarithms, and base 10 we normally use the term common logarithms. So before we do that, I thought I'd just go over something that's just a little formula here. It's called the change of base formula, and it comes from the last video where we were talking about how you use logarithms to solve index equations. So if I have 2 to the x equals 8, this is a simple equation to solve. We don't need logarithms for this one. The answer is 3. But one way that we could solve this is by taking logs of both sides. We get x log 2 equals log 8. X is log 8 divided by log 2. So we know how to get the answer for that one there. But if I rewrite this statement now as a logarithm statement, then I would get something that looks like this. Log base 2, because the base is 2 there, of the number 8 is equal to x. Okay, so if I want to find what log base 2 of 8 is, you can see that the solution is log 8 over log 2 using this formula. So x is log 8 over log 2. And now we could get our calculator out, and this could just be base 10, and we could work out what the value of x is, which here is going to be 3. But this is really cool if you extend this to any kind of logarithm. If I say log base 4 of 8, let's say. So this one here is a little bit trickier, log base 4 of 8. But I know if I just follow the same pattern that we did over here, it's just log of this number divided by log of this number. So this is just going to be log 8 divided by log 4, with that's base 10 for these logarithms over here. So therefore, any kind of log of any base, we can transform like this. So this is called the change of base formula. So if I write it out in general, log base a of b is log b divided by log a. Okay, cool. Okay, back to natural logarithms now. A natural logarithm, as I said, is a logarithm with a base of e, Euler's number. So we normally don't write log base ex. We normally use this abbreviation, which is lnx, or natural log x. So you'll hear me say ln of x, which means this thing here, which is natural log of x. So it implies that the base is the number e, which is, as we know from before, is about 2.718, etc. Looks like this. So we're going to get into graphs in the next video, but there's y equals e to the x, that exponential function, and you can see the y equals ln x is the inverse of that function. So it's just a reflection in the line y equals x. That's graphically the relationship between a function and its inverse. And so here's the graph of y equals ln of x. It's important to realize that these two functions are inverses. So when we go ln of e of x, we get back the original number. If we go e to the power of ln x, we get back the original number. So as I showed in the last video where we were solving equations, this is really helpful to understand that relationship. So how would we use a calculator then to find these? So ln e cubed. Well, we know that ln of e is equal to 1, so this is just equal to 3 ln e. Now let's look at this thing here, ln of e. This says log base e of the number e. So that means e to the power of something is equal to e, so that is obviously, x is obviously got to be equal to 1. So that's a basic log rule that we have. Log base 4 of 4 is equal to 1. Log base x of x, anything, is equal to 1. So log base e of e is equal to 1. So the answer to this one here is 3. ln of 1, we know ln of 1 is 0. Everything. Ln of log of 1 of any base is equal to 0. Ln the cube root of e. Okay, the cube root of e is e to the power of 1/3. So this is equal to 1/3 ln e, and again ln e is equal to 1, so this is a third. ln 1 over e squared is just ln e to the minus 2, right? 1 over e squared is just e to the minus 2, so again we can bring that number down the front and we get negative 2 for that one. There's another way that you could think of this question here. ln 1 over e squared is ln 1 minus ln e squared. Okay, just using that second log rule that says log a over b is log a minus log b, and so that is 0 minus 2 ln e, so 0 minus 2, which is negative 2. Okay, write these as a single logarithm. So for part A, 2 ln 7, so this is going to be ln 7 squared minus ln 2 cubed, so that is ln 49 minus ln 8, which we know is ln 49 over 8. So there we go, I've written it as a single logarithm. Now this is no different from any of the other questions we've done. This is just in the context here with natural logarithms. So this question asks, write the following without logarithms. So let's have a look at part A. This is a bit tricky. So ln a is equal to 2 ln c plus 3. Again, to undo ln, the opposite of natural log is e to the power of. So that's what I'm going to do here. I'm going to go e to the power of both sides and be really careful. So e to the power of ln a is e to the power of 2 ln c plus 3. Okay? So again, make sure that you don't do on the right hand side e to the 2 ln c plus e to the 3. It is not that. You can't just apply the function to each individual element on one side. It has to be to the whole thing. Okay, so e to the ln a is just a. E to the 2 ln c times e to the power of 3. Okay, again, so if we're multiplying and the bases are the same, we add the indices. So it's often easier to see this step backwards and that works. Okay, e to the 2 ln c is e to the ln c squared times e cubed. And now I can see that e and ln undo each other. So this is just c squared and this is times e cubed. So there we go. We've written that following equation now without any logarithms. A is e cubed times c squared. So now we're going to apply this to solving an equation. E to the x plus 1 is equal to 5. So if e to the x plus 1 is equal to 5, again, we could use log base 10 here, but it's a lot easier when you see the number e in there, use natural logarithms. So ln e to the x plus 1 is equal ln 5. Again, this comes down the front, that rule of logarithms. X plus 1 ln e is equal to ln 5. We know that ln of e is equal to 1 always. So x plus 1 is ln 5, so x is ln 5 minus 1. So you could leave it exactly like that as an exact value, ln 5 minus 1, or you could get your calculator out. So this time I'm using the natural log button, ln 5, and subtracting 1. So it gives me 0.609 to 3 decimal places, or to 3 sig figs. 4 decimal places would be 0.6094. There we go. Here's another example here where we're solving the kind of equation we did before, but instead of using log base 10, we're just using ln. It looks exactly the same as we did before. It just shows that you can use natural logarithms in other kinds of questions as well in solving these equations.